pretty sure my editor is going to have a really good time putting in like little annotation bubbles saying how stupid I am and that it's 0.05. But I had to check a calculator. I feel really dumb right now. It is 0.05. 1 over 20 is 0.05. I feel real stupid. So yeah, it's 0.05. 1/20th. 1 over 20. Fractions. Oh my God, fractions. I'm a doctor, for God's sakes. 0.05. Okay. Anyway, so that's how you do the activity of something. It's just time to endpoint per second. Like you just do 1 over time to endpoint. That's all the activity of something is. That's all it is. All right. So let's move on. These questions, how you set up control, I believe we've already recorded that actually, so we'll just cut that in here. But that was fine. Like how we recorded that was fine. All right, so end of splicing in, and now we'll just record over this for this question. Identifying one significant source of error in this investigation. Basically, you are always the significant source of error. Effectively, human error is pretty much it, but you never write it as human error. It's always something that you do that is the error. It's always your measurement technique or your, not your equipment. Never complain about the equipment, but always something you using the equipment or you measuring with the equipment. You having difficulty telling when the endpoint is reached, for example, like difficulty in color change, for example. For example, how I messed up the reaction the first time, exactly as I messed up this reaction in this video, how it's difficult to tell when that endpoint happened. That is exactly what I messed up, is I misread the endpoint of the reaction the first time, and I shell gamed myself. I mixed up the things, and the pink changed to white almost exactly as I was covering them over with my hands. Or the timer was still going as I was writing down the numbers. So it's very difficult to tell exactly when the endpoint is. It's difficult to say exactly when something is just slightly pink or just slightly white. It's always human error in telling exactly when time is running or time is, or when something is colored differently or not differently. So it's always your ability to tell when something is or is not exactly perfectly on the line. That is always the human error. That is always the source of error. It is always that. It is always your ability to tell the endpoint or the measurement line. It is always about you. That is always the error. So it is always, that is always the source of error. You are always the source of error. Now, the part B. Whenever you're reading these graphs, the type of milk and the time taken to the end point, these are always just interchangeable. It's always about X and Y, your X coordinate and your Y coordinate plane. So your X-axis and your Y-axis. This is going to be your X-axis heading, type of milk. So this is always going to be type of milk down here. And your Y-axis, this is always going to be your Y-axis over here. And you're just going to copy that. Type of milk, type of milk, and time taken to reach endpoint. Time taken to reach end point / seconds. Just going to copy it verbatim. Now, let's actually cut here.